So here's part 2 of our lecture on balancing chemical equations. One of the problems that we will do actually involves the use of fractions. So you definitely want to be wary about fractions because not all chemical equations will come out so clean, giving you nice whole numbers. Anyways, we'll come across that problem a little bit later on. First, let's just do another equation that we can balance here. Remember, all the time is that reactants go to products. So that is sort of the mantra I want you guys to realize. Reactants go to products through that arrow. And let's just take an inventory of the atoms. So here we have nitrogen, hydrogen, and then chlorine. So in nitrogen of ammonia, there is one atom. This is called ammonia. And in ammonia, we have 3 atoms of hydrogen, and in diatomic chlorine, we've got 2 atoms of chlorine. All right, so law of conservation of mass. Okay, every atom must be accounted for. No atom must be created or destroyed in our chemical reaction. So let's take a look at this here. We have, this molecule is called hydrazine. It's not something you really need to concern yourself with. This is ammonium chloride, the ionic compound. So the number of nitrogens here is going to be 2 plus 1 here is 3. So that odd number is a little bit concerning, but we'll deal with it. The hydrogen here is going to be 4 hydrogens plus 4 hydrogens gives us 8. And the Cl here is just 1. Okay, so trial and error is what I usually like to tell people when they embark or, the mode of attack. Go for the simplest one. And to me, what I see is the simplest one is to just, because you have the chlorine here as a loner, and you have a chlorine here as a loner as well. Here you have the nitrogens on both products. So I'm going to go for balancing the loner. And to do that, I'm going to put a 2 here in front of the NH4Cl, ammonium chloride. So that's going to give me 2Cl, which is good. But what about the hydrogens? That's going to mess this up. So 2 times 4 hydrogens is 8. 8 plus 4 hydrogens is 12. That will also alter the number of nitrogens. So here I have 2 nitrogens plus the 2 nitrogens here gives me 4. So now the goal here is to try to figure out how will I balance out the nitrogens and the hydrogens. Well, one thing I can do here is put a 4 here. Now, if I put a 4 here, I have 4 nitrogens, and I have 12, 4 times 3, 12 hydrogens. Yeah, this is balanced. So 4 moles of ammonia plus 1 mole of chlorine, diatomic chlorine, goes to yield 1 mole of N2H4 plus 2 moles of NH4Cl. So this equation is balanced. All of the atoms are accounted for. All right, let's do one more problem here. This one's a little bit more complicated. It's the combustion reaction of C6H6, that's known as benzene, plus oxygen goes to CO2 and water. Most combustion reactions yield as products CO2 and water. So remember, reactants go to products. Let's take an inventory here. We have C, H, and O on our reactant side. Reactants go to products. And in our product side, we also have C, H, and O. Nothing more, nothing less. So our carbons here is going to be 6. Our hydrogens here are going to be 6. Our oxygen here is going to be 2. Our carbons here is going to be 1. Our oxygens here is going to be, let's do the oxygens here, 2 plus 1 is going to be 3, and our hydrogens here is going to be 2. Okay. So go for the easy bait. The easy bait, in my estimation, is going to have to be the carbons. So if I'm going to put a 6 here, and the 6 here automatically balances out the carbons, because now I have 6 carbons here and 6 atoms of carbon in my reactant side, it's going to alter my oxygens. So my oxygens are going to be 6 times 2 is 12. 12 plus 1 is 13. Okay, so anytime you have an odd number here, though in the previous examples and the previous videos, we were able to not employ a fraction. But just be aware there could be a fraction involved here. And what is our hydrogen count? Our hydrogen count is 2. I can balance that out easily by putting a 3 here. So 3 times 2 is going to be 6. First of all, let's see our oxygen count. 6 times 2 is 12. 12 plus 3 is 15. So now we need to balance our oxygens. We have 15 oxygens total. 6 times 2 is 12, plus the 3 oxygens here is 15. So how will we go from 2 to 15? Okay, so you can put a number here, this being our loner. We can put a 7 here. If I put a 7 here, just, it's not the right answer, but if I put a 7 here, 7 times 2 is 14. Okay, so we're 1 off. Okay, if I put an 8 here, okay, that's not the right answer, but 8 times 2 is 16. Okay, I'm 1 off, I'm 1 more. So you're going to have to use a fraction, and it turns out the correct fraction that you will use is 15 halves. So trying to squeeze that in here. So here the 2 and the 2 cancel, like in a math equation, and that will yield to 15 oxygens. That balances this out. So once again, just to reiterate, to balance this equation, you'll need 15 halves because the 2 here and the 2 here cancel out, giving me 15 oxygens in my reactant side. All right, so what we can do is multiply both sides of the chemical equation by 2. So when we multiply both sides of the chemical equation by 2, okay, kind of like you do in algebra. So that's going to be 2 times C6H6. Okay, 2 times 15 halves is going to be 15O2. 2 times 6CO2 is 12CO2. And 2 times 3H2O is 6H2O. And that should be our final answer. Okay, so we can do a check to make sure everything is okay in balancing it. So it's a way to validate your answer, make sure you got the right answer. So carbon, hydrogen, and oxygen in our reactant side, carbon, hydrogen, and oxygen in our product side. So carbons, 2 times 6 is 12. Carbons here, 12 times 1 carbon is going to be 12. Hydrogens, 2 times 6 hydrogens is 12. And hydrogens here, 2 times 6 hydrogens, okay, 6 times 2 or 2 times 6 hydrogens is 12. So that's a balance and that's a balance. Now let's look at the oxygens. 15 times 2 oxygens is going to be 30. And in our product side, okay, we have 12 times 2 oxygens. 12 times 2 oxygens is 24 plus 6 oxygens times 1. Because we have 6 atoms of oxygen in 6 moles of water. So it's going to be 12 times 2 is 24 for CO2, oxygen, and 6 times 1 for oxygen here, so 24 plus 6. The answer is 30, and this is the balanced equation. So I threw that in here because sometimes you will get fractions, and when you have a fraction, it's always best practice to multiply the whole, like you do in an algebraic equation, multiply by the denominator to clear the fraction.